Thank you very much and welcome Zagreb. I've been trying to come to this conference for the longest time. We were debating yesterday. I think it was like 4 or 5 years that I've tried to actually attend. But then first we had COVID and then some other stuff happened. So I'm super happy and super excited to be here this morning to be able to talk to you about why you shouldn't run databases in Kubernetes. And I talked to someone about this yesterday and he was completely excited because he thought it was such a good idea not to run Postgres in Kubernetes. Well, a little bit spoiler alert, the talk is actually going to disprove that a little bit. For those how many of you are familiar with Postgres? Cool, that's a good group. How many of you are familiar with Kubernetes? Cool. Not necessarily the same people, I hope. But one of the things is Postgres is one of the most transformative technologies since Linux. The reason why I'm saying that is, what we've seen, and I've talked about this in other conferences before, we've seen various waves of open source coming through, the world. It started with, basically with the first adoption of Linux, which replaced a lot of these very, traditional operating systems. And basically, if you go out into the world, most systems are now running Linux. But it was Linux running some proprietary data management systems and other, technologies, because simply the feeling that you could have, an open source system built by, geeky people in basements or in attics smoking funny stuff, and actually using that to run mission critical data management systems. That wasn't really, feasible up to, I think, 10 years ago. When Postgres really started to come up as the open source alternative for data management. Just a little bit about me. I'm a techie in sales, so I started out in technology, but in the recent years ventured off into the dark side of things and actually currently running a sales organization, but still very much connected, try to stay connected to the technological side of things. And I'm a little bit on a mission because I think, if you look at the world today, if you look at a lot of the changes that are coming into our field, and we've seen that with the opening keynote, right? With the emerging of computers and the interesting fact that actually a thread in a computer program is actually coming from a thread in a Loom machine. That was a very fascinating thing to learn. So that kind of evolving matter is something that's coming to application development, that's coming to our everyday life. Who's using, banking on their phone these days? Right, so that is one of the topics that's actually weaving into this a little bit. And to kick things off right away, I start with this super fascinating slide. It is about, databases. Where did databases come from? In the early 1970s of the previous millennium, yes, it's that long ago, there were these two guys who were building relational database theory. Ted Codd and Chris Date. My boss actually has a dog which is called Edgar, for Edgar Codd, and I've actually met Chris Date once. So, this is the guys that have built the foundation of, actually that banking application that you're using. It was in IBM, in Silicon Valley back in the days. They built relational database theory, implemented that in System R, which was the first real implementation of relational database theory. I originally come from an Oracle background and everybody thought, Oracle is the mecca of databases. Wrong, it's IBM. Because in IBM, in System R is actually where, the database journey started. From that same guy, Larry Ellison, took relational database theory and started in his company software laboratory started, implementation for the CIA, and that was, he later rebranded his company to match the project name, which was Oracle. In that same time, there was another guy also roaming around in Silicon Valley, working for Berkeley University, looking for inspiration to start working with his team of co-ops to build a new solution. He adopted relational database theory, and at the University of Berkeley, he started Ingress. So Ingress is based on relational database theory, and it was, a good system. Dr. Michael Stonebreaker, who the associate professor was, then took, Ingress to Ingress Corporation, did that for a number of years, and actually learned a couple of very valuable lessons on running database systems. And one of those is, the anecdote goes a little bit like he was on the phone with the customer, said, in my system, I have this very cool date format. It's the Gregorian calendar. It takes, leap years into account, and, it does everything very cool. And the customer said, well, dear Mr. Stonebreaker, that doesn't help me. Because I have a business which has 12 months, and every month is 30 days. So why would I need the Gregorian calendar? This guy was doing in bonds, interest rates, and he would always calculate 30 days for a month. That sparked the idea in Stonebreaker to say, wait a second, so my system isn't perhaps perfect after all. So he went back to Berkeley and started the post-Ingress project. Post-Ingress, Postgres. In the Postgres project, what he did was implement the extensibility system. So in Postgres, you're able to create your own data types. So you could create the data type with 12 months times 30 days. But you would also have the ability to do, your own programming languages, your own operators for data types. So there is very much ability in Postgres to build specific things. And one of the cooler things, in my opinion, is the JSON data type, for instance. So Postgres is actually, and this is a very badly known fact, actually in Postgres you're able to do relational data and document-based data in the same engine, actually with the same data. So for a developer, front end, Postgres can be your JSON document store. On the back end for data analysis, you actually have just a relational model on that same data. So you can index it, and you can query it, etc., etc. Extremely powerful feature. Deriving from the insights of Michael Stonebreaker back in, what was it? Early 80s, mid 80s of the previous millennium, right? With that, you have a data engine which is very small, very agile, very extensible, and being able to be used almost anywhere. Keep that in mind. What I talked about a little bit is, that banking application. What you see is, and this is a little bit the lay of the land of today, right? It started with Postgres, and then, this concept of cloud started to emerge a couple of years ago. And additionally, the mindset of cloud native. Cloud native is really not necessarily about cloud. It's not necessarily about, a technological way of looking at things, but it's really a mindset thing. And I will dive into that a little bit in the next slides. With that in mind, going to application development, right? Back in the early days, and that was the days of where the opening keynote also spoke of. When you started building applications, you had this fixed process, right? You would do a preliminary study of what would the application need to do. Then you would start building a logical application model. From that logical application model, you would start building a technical design. You would start, looking at the data model. You would start looking at a lot of these things and features that needed to be built, you would devise a test plan. That sounds a lot of work, sounds like it takes a lot of time, and that's true. What you end up with is like a sturdy locomotive, an oil tanker, if you like. It's capable of doing its job very, very well. But it's also very hard to steer, right? If you have an application, a core banking application, which is now 40 years old or something, running on a mainframe, today it still functions, right? Your core, banking, your bank, what is it? The amount you have in your account, the management of that is still often done by these systems, which are 30, 40 years old, that nobody dares to touch anymore. I think that was the question about who knows COBOL, right? These systems were written in COBOL. They were written like the steam train. On the other hand, and that's linking that to who does banking on its phone. A lot of you guys do banking on your phone. That requires a completely different approach, because phones and your requirements of how you want to interact with your bank account, they change like the flock of sterlings. Who's ever seen a flock of sterlings flying in formation through the sky? This is a very cool natural phenomenon. Like every single bird just looks at its neighbor, right? If that, goes a little bit to the left, the other one also goes a little bit to the left. So you get this, magnificent movement in the sky. In my idea, application development these days is a little bit like that flock of sterlings moving through the sky. A little bit needs to be added, but it can't be changed. You can't, shoot all the birds down, put them in a different formation, get them to fly again. That just doesn't work like that, right? So you need to be able to influence each and every granule of the application to be able to, quickly and swiftly start doing the things that you're requiring of it, right? And that, as we are very good in IT these days, leads to buzzword bingo. So get your cards out, because here we go, right? Agile application development. Agile frameworks, how do we need to start working with this? Microservices, who's built microservices before? Few guys, cool. DevOps is also one of those. Let's just cross it off the bingo list, right? And CI/CD, continuous integration, continuous delivery. It sounds like buzzwords, but if you stop and look at these individual elements, they actually all have a place in building applications that go towards, that same kind of agility. And I had a very interesting discussion as well yesterday with a couple of guys on, what do you need to understand about this? Is it enough to, get the thought of what this means? And I think at some point we came to the analogy of the introduction of Windows back in the day, Windows 3.11, where all of a sudden copying a file became, click left and drag the file from one folder to the other. That could result in, a file being copied locally from one place on your hard drive to another place on your hard drive, but it could also mean that you actually copy a big file from here to the United States, which back in the day could cost you $10,000 or something, right? Buzzword bingo is one of the bigger dangers in this story. If you just take this and don't start thinking about it and don't start, mapping this to features and requirements that you in your organization actually have or need. That being said, drilling into DevOps, and especially where it comes to, the main track of what we're talking about, which is, how do you run databases in Kubernetes? Where does it make sense, etc. For that, understanding DevOps, understanding the cloud native mindset a little bit, I stumbled across the DORA framework. which is not the cartoon, by the way, but this is the Google DevOps research and assessment. It's in the bottom. There is actually a survey going for DORA for the 2024 report. So I unfortunately haven't linked it here, but please go find the link. And if you are into the field of DevOps and agile application development, please participate in the survey, because the more we learn about how this works and where does it play, the more value we will get out of it. The DevOps mindset, the cloud native mindset, goes towards a lot more than just building agile applications, but actually how do you do this and where are elements which are part of it. So if you start looking at how do you move from that steam train to that flock of birds, this is a little picture that has the elements in it. So you develop, you do peer code reviews. We saw in the previous keynote, the important role of GitHub, the important role of version management. So that's another element in here, but building an application and making sure that, if a bird changes position in the flock, the other birds don't fall out of the sky. You will need to test. And you will need to test again, and but it can't be a manual process. Because one of the things that you're looking for is to have very many releases very quickly after another. So this needs to be integrated, this needs to be incorporated. So testing, test automation, test data management. And from the CI/CD part, I always thought I was the most scared of CD, continuous delivery. But actually, if you start thinking about it, the most scary part is CI, continuous integration, which dictates that your application should always be in a state that you can deploy it. Not that you do it, but that you can do it if necessary, right? So that requires that the application, after each change gets tested, that errors get found and bugs get found and fixed very, very quickly. And this is, again, where containers and the deployment start coming in, where test data management comes in, and a lot of these elements start playing a role. Linking that back to DORA means figuring out, what does this process look like? How does it function in your organization? And basically, it talks about KPIs. What is your lead time for change? How quickly, if a requirement comes up, can you actually implement it? Deployment frequency. Actually, the steam train would deploy once or twice a year. If we look at Postgres as a project itself, it has a major release once a year. If you look at your banking application, it's not even the concept of major releases, but changes get introduced on an hourly basis, if necessary. But talking about how often can you actually start rolling out incremental improvements to your application? But also, if something goes wrong, how quickly can you restore from a problem? How often does it go wrong? And the rise of the SRE, system reliability engineering. How reliable is the end result of what you're building? This is what DevOps and the cloud native mindset and the DORA framework focus on. And if you take all of that in mind, this was just a funny thing because I always wanted to kind of show this. What is cloud? Well, mostly Linux servers, right? Keeping all of that in mind, you get to basically an application becomes a more or less a neural network. Like the flock of birds, all of these individual elements communicate with each other, and this is also where data management starts to become a part, right? Because connecting something that is so flexible really to, with a big pipeline to that old framework, to that old mainframe somewhere in the basement, might not necessarily be, the best way to do this. And this is just for you to read, and will we be sharing the slides afterwards? Yeah. So you can read it then afterwards. But I just wanted to capture once more, what cloud native actually means. So what we've now seen is, Postgres on the one hand with the extensibility system with its, small footprint and many opportunities and options, and the agile application development that's required today. So we would like to bring those two together. The very cool thing for an open source conference is that actually both of these projects are community governed open source projects. I think it's very important to grasp, the difference between general open source and community governed open source. So what we are doing now is taking the Postgres community, bringing it together with the Kubernetes community, and that results in another community governed open source project called Cloud Native PG. Running databases in Postgres is just like, many things, not something you would necessarily want to do by hand. You can do it, like you can deploy Postgres by hand, or like you can, build your Kubernetes environment by hand, but it's not necessarily the most ideal thing to do. So what we did is, create an operator that runs Postgres, but does it the cloud native way. And that makes it a little bit, interesting and really also fitting into what actually the CNCF, who's the owner of cloud native, so to speak, has in mind for, if you build something which is cloud native, so to speak. So you can deploy anywhere. If you have a Kubernetes cluster, you can run Postgres. It will help you, and I will dive into that a little bit in the second part. It will help you automate DBA tasks. And, as it's a community governed open source project, there is actually not a vendor that, locks you into their proprietary solution. And then at some point, like we've seen with multiple occasions in the past, change the licensing model and all of a sudden you're in a vendor model. Just a little bit about, is this a valid solution? So there are like 5 major Postgres operators in the field these days. Cloud Native is a little bit late to the game, perhaps. May 2022, we released Cloud Native PG to the community, and you can see the adoption rate compared to some of the others. So the blue and the yellow line are the major, most used Postgres operators today. And, Cloud Native in just under 2 years, or just 2 years, almost matched already, the deployment degree of the other ones. So what actually does it do, right? It's a Kubernetes operator. It helps you to do day 0, day 1, and day 2 operational tasks for Postgres. It was originally developed by a company called Enterprise DB. At that time, I was working for that company. I was involved in releasing Cloud Native PG to the community. It's an Apache 2 licensed tool, so it's free for you to use. There is its own website. The QR code will take you to that. And it's an open source tool for anybody to use. So if you have a Kubernetes cluster, you pull down the Cloud Native PG operator, and it will help you deploy Postgres from the start. And that will take you into preparation, deployment, and day 2 operations for Postgres. So this is really where, the fun starts, thinking about, how do you start running Postgres? Is your Kubernetes cluster, so there are some prerequisites, especially around storage, and that has to do with, the same discussions we've seen in the past when, the old discussion always was, well, I'm running a database, it's running on a bare metal server, but now I need to start running on virtualization. I don't like that because, you know, it's scary and it's got no direct attached storage and all of that. All of those same arguments that were used when we started using virtualization for database deployment, you know, those same arguments are now being used for running, you know, Postgres in Kubernetes. This is scary. It's like agile, and the, you know, a pod can die at any moment, and you shouldn't do it. And I can promise you those issues are tackled. We're running Postgres in Kubernetes already for at least 3-4 years in production in many places. So, you know, this is something that works, but just like any deployment, if it's a bare metal server, if it's virtualization, if it's in Kubernetes, you have to at least, you know, plan and understand what happens. The actual implementation is just a kubectl command, right? It's completely declarative, so you go away from, you know, originally, you know, defining how you would install. So there are many steps to building a Postgres cluster, but by doing this in, you know, a YAML file in a completely declarative way, you know, you just get to answer a couple of these questions. And this is actually what we want to build, you know, a 3-node Postgres cluster that, you know, has the latest version of Postgres, that has, you know, a set of storage, a set of memory, etc. And actually building that, you know, gets boiled down to entries in a YAML file. Cool thing, if we look back at how we deploy databases and infrastructure today, right, is actually using YAML, because, you know, building a server by hand, you know, downloading a Linux distribution, downloading software, you know, it's not really what we do, right? It's old school. We have, you know, our deployment frameworks. We have, you know, all of the tools where, you know, we can actually version management, all of this stuff. So also in this area, and if you start thinking back, you know, to the intricate picture where all of these individual elements were defined in, you know, the deployment process and the build and test process, you know, you can't do this by hand. This needs to be infrastructure as a code, if you like, built in these kind of files. So that is, you know, the imperative way of doing this. And basically then the deployment gets to be, you know, a kubectl apply for that YAML file, and you will end up with basically a 3-node Postgres cluster exactly as we've defined it in the YAML file. The way that, you know, Cloud Native does this, Cloud Native PG operator does this in Postgres or in Kubernetes, is actually use the elements of the Kubernetes cluster manager, where it comes to, you know, networking, where it comes to services. You know, it builds a read-write service, it builds a read-only service, it uses the elements of the Kubernetes API server to basically do the Postgres database management elements. And that's what makes it A, easy, and B, also future resistant, or future persistent, I should say. You know, if people start building and extending the Kubernetes API server and add new capabilities to that, you know, you don't have to change a lot of the other tools. By using the operator, by using the Kubernetes API server, you can actually leverage parts. So in Kubernetes, data mesh is a big topic. So I know that the Kubernetes or the Cloud Native PG team is actually looking at how can we start using data meshes to augment, you know, the network services inside this management, you know, to drive that forward. What I said, you know, there is the read-only service, there is the read-write service. So a lot of the application management for working with the database is actually resolved by leveraging the Kubernetes server. And it does a lot of the other elements that are required to run Postgres in a secure way inside of Kubernetes. And by the way, it says it here. Can I do it like that? Yes. Convention over configuration is basically what I meant by, the declarative way of, deploying Postgres. But also, if you want to update it, it's again changing something in the YAML file, adding a couple of CPUs, adding some memory, and basically applying that, YAML file to the operator. And the operator will then, make these changes inside the deployment and also make sure that Postgres can actually use that. A cool thing also in running Postgres using the Kubernetes operator in comparison to, some of the standard ways that we all consume Postgres in the cloud these days, which is, using RDS or using, Microsoft implementations. The degree of control that you have over the parameters in Postgres using this methodology is a lot bigger, right? Because it's pure Postgres. We have complete control over what we do. And it gives you a lot more ability to, manage and run Postgres just like, you need it to work. Where if you run in a hyperscaler service for a relational database management system, often a lot of these parameters are, limited for you to tune and to work with. The operator then starts doing, if you want to reload parameters for those of you who are familiar with Postgres, but also, rolling updates, rolling upgrades, all of these elements are built into the Postgres operator. And basically, bringing all of that management back to, I'm actually just changing a parameter. Going from one minor or major version in Postgres even, it's just changing a parameter. And this is also the scary part when we look back at, moving a file with a click of a button. Changing a parameter here can have and will have significant impact on your Postgres service, right? So this is still something that you need to be aware of, that needs to be part of your test plan and all of those kind of considerations in that sense. So from there we go to day 2 operations, and hooray, actually the cloud native PG operator is a database, a DBA in a box, if you like, right? Because it will do all of the maintenance tasks that you would do by hand, I mean, regularly. Now the Postgres operator will take off of you. And we've been talking about, the changing role of a DBA for many, many years. And I think one of the things is that this is just another step into the evolvement of that process, right? A DBA would usually, back in the day when I started, the DBA would, start looking at which kind of server would I need. And that, when servers got virtualized, you didn't have to think about that anymore. So you started, stepping one step back. And a lot of people thought that was scary, but actually it's a very cool opportunity because all of the boring stuff, gets to be put in the box. And you will still have to know what it does, but you don't have to do it anymore. And that kind of makes it cool. Same thing with, patching and upgrading. Who really wants to sit on a Sunday evening at, 7 p.m. in a data center doing, database patching? Whose dream is that to do that? Yeah, obviously Hans, but we ordinary people would rather sit, with a good glass of wine or a good beer in the garden, right, looking at the sunset. So this is all of the stuff which is incorporated in, this part of the operation. That goes for, monitoring with the Prometheus, backup recovery. All of these elements are part of what the Postgres operator does for you, right up until restoring after failure, etc. Again, this is stuff that you should start trying. So if you get back to your jobs on tomorrow, or for those of you who will be in the conference here on Monday, just start trying this out. This is stuff which is free and available for everybody to use, right? Including, looking at Postgres replication. So in Postgres, high availability is the standard. It's not something which is optional or which is, costly or extra. It's just the standard. And I think I talked about a bunch of this stuff. So if something goes wrong, right, failing over or even switching over from one node to another and actually doing, primary and replica switches is completely managed also again by the Postgres operator, which is, something you would have to build, test, and be aware of. And that's abstracted away and put in that box, making this, a lot easier to work with. So coming up to some closing remarks, and this is what I was actually talking about already a little bit, changing the DBA role, stepping away from the mundane day-to-day tasks and really start to focus on, hey, but if my database is actually part of this changing application landscape, can I move data management to the edge, if you like? So can I take data out of my basement and actually incorporate it in this flexible layer that we're building? I've been working with a Polish insurance company. It's one of the larger insurance in Poland, who actually have a mainframe in the basement, and actually made this same decision, right? We're going to take the services that this mainframe was building to us. They've defined like 50 services or something. We're going to take that service by service, take it out of the basement, put it in Kubernetes, make sure that the application landscape as it evolves is able to use these services in the way, that, today we look at data management. Cloud Native PG, this Postgres operator, is one of the tools that allows you to do this. And this is community governed open source, right? So please look at the website. Please go find, the Slack community. Please go find, where you can start contributing. Everything is completely taken care of in the mindset of, Cloud Native, including the contributors file and a lot of the elements that you would need to quickly get started in not just using, but also contributing. There are still a bunch of very interesting things that we want to teach the operator, but teaching the operator to do it requires people that actually want to teach that. And that's, in this case, writing code, right? So with this, you're very much invited to become part of the Cloud Native PG community itself. And this is my personal call to anybody who thinks, hey, Postgres is actually very cool. We're hiring, so if you want to be part of the Postgres community as well as the Cloud Native PG community, for both, come see us. Hans is in the back, I'm here, we will be here the entire day, and we're looking for you. Questions?
Okay, so I see a question in the back.
Hi. So I have a question about patching and rolling, patching of the pods. So if we do that, we will obviously switch the master at one point, or primary, whatever you want to call it these days. And wouldn't that break the connections from application and potentially also break the all the queries that are already running? Like, does the operator take that into account? If we have a long running query, will it wait for it to finish gracefully, or will it just kill all the running queries during that operation? Thank you.
Very good question, and this is not necessarily directly related to Postgres and Kubernetes. This is a general process, as this system isn't capable of working on a query. So Postgres is a shared nothing architecture, meaning that everything is contained into that one cluster. So to answer your question quickly, yes, all the running stuff gets killed. This is also one of the reasons why, again, in the testing part, this needs to be part of your test plan. It needs to be done at a sensible time if you do this in production, right? If you want to do an upgrade in production, you will probably want to do it at a period where there is a little usage. The cut over point, by the way, is very briefly, right? So the running transactions get killed. So if you make sure that you have no long running transactions, but only the short stuff, it's simply given to the driver, like the connection is gone, please retry your query, and by that time, the replica is up, and the query will succeed the next time. So it will feel like a network hiccup while you're actually doing version upgrades. Does that answer your question? Go.
Any other questions?
Thank you. We are running the databases in containers, and I have one question regarding to the performance. All databases require huge pages, and there is a limitation on the operating system how many huge pages can you actually have. So what does actually happen on Kubernetes node, which have 200, for example, Postgres installation?
So those are questions where it comes to, if you're running in traditional environments, you have just the one operating system, right? So this is a specific issue when it comes to running databases in Kubernetes, because Kubernetes, as you might know, is just, one big operating system. So that's a very valid question that you would have to take part into the design of how are you going to deploy Postgres on Kubernetes. So there are multiple ways. I've seen organizations which build specific clusters for databases, but also organizations that say, I have a mix and mingle where you can dilute the requirements for for those numbers a little bit over multiple nodes. But it's indeed something that you would need to look at, perhaps with taints or something on nodes, where you can say, I can only run so many of these specific pods on one specific cluster. But yes, a very valid question.
Hi. We are currently in the process of moving like 20 Postgres databases into Kubernetes, but unfortunately, I'm not the one in our organization that is doing that part. My colleague, he should be here. That he would have a lot of questions for you. But as far as I know, we are not using this cloud native software. I think we should, after I've seen this presentation. I will certainly show this to him, but I showed him the title of this talk, and he said, nah, this guy doesn't have a clue what he's talking about. We can do it, yes. My question is it too late to implement this? We are just in the middle of the process. We just migrated like 15 servers from 20.
This is something you can do seamless. It's a Postgres operator, so if you have databases running in Kubernetes already, what you can say, you need to check things like, which container image are you using? Does it actually fit in the working of the operator? Most likely it will, but you can ask for guidance from the guys on the Slack channel, the Cloud Native PG Slack channel, and they will have answers for you.
So we can do it retroactively, right?
Yes.
And if we don't do it, what could possibly go wrong? We could lose it.
What could possibly go wrong if you don't do it like this? That's a very interesting question. My answer would be not necessarily a lot, but it would probably mean that you have a lot more homework, because a lot of the homework is abstracted away by the operator. So if you don't use the operator, you will have to do the homework yourself, right? You can write your own Postgres operator, not a problem. But it's not that easy. Yes, you're welcome.
More questions? If not, I encourage you everyone to thank all of our keynote speakers once again with a big applause.